All right, we're back. We are on page 6 of notes 8 of Calc AB, and it looks like these are just review problems, so let's see how quickly we can do them. So first up, we're going to find some critical points. So f prime is going to be first. Derivative second is going to be, so it's 3, but then you pick up another 2, so -6, 7 minus 2x squared, plus second, 7 minus 2x cubed, and then it'll be 2, but you pick up another 3, so 6, 3x plus 1. And then we want to try to factor, so I can take out 3x plus 1. I can take out a 6, actually, a 7 minus 2x squared. That'll leave me with -3x minus 1, and then plus 7 minus 2x, I think. So that'll be 6, a 3x plus 1, a 7 minus 2x squared, and then a -5x plus 6. Okay, so critical points. Points in the domain of the function in which the derivative is 0 or undefined. So the critical points in this case are going to be x equals -1/3, x equals 7/2, and x equals 6/5. Should we check that on a calculator? I guess. Let's do it. So swap to the calculator, and then I need. So I'm going to do it all in one shot. Solve, then derivative. So let me move this over here. Derivative with respect to x of 3x plus 1 squared and 7 minus 2x cubed equals 0 for x. -1/3, positive 6/5, and positive 7/2. So we got it. All right, that's one down. Let's see what else we got to do. All right, so write the point slope equation of the line tangent to the graph at y of y squared minus 2xy equals 16 at 3, -2. All right, so first I need to find the derivative. So I'm going to go like straight into it. So I'm finding the derivative of this. Derivative of y squared, 2y dy dx. And then I treat -2x as the first and y as the second. So it's going to be first derivative of the second plus second derivative of the first. And then that equals the derivative of 16 is 0. Biggest mistake I see people make. So what I'm going to do now is I'm going to plug in this, because it's just easier to plug in and do arithmetic than it is to like algebra and then do that. Although, I mean, it's not going to be bad no matter what, I think, in this case, but we'll see. -4 dy dx minus 6 dy dx, and then plus 4 equals 0. So dy dx at 3, -2 is equal to -4 divided by -10, so positive 2/5. But we want the tangent line. You should always write your tangent lines in point slope unless otherwise stated. So y plus 2, 2/5, x minus 3. I think that's our answer. So I'm going to check that, but first I'm going to do some more problems, I think. So let f be the function given by that. What is the instantaneous rate of change is another way of saying what is the value of the derivative. These are things you need to know. Questions try to trip you up by just using different words, and that's kind of silly because, you know, why would this trip you up? But so f prime is 15x squared minus 6x plus 6. So f prime of -2 is going to be 60 plus 12 plus 6, so 78, I think. All right, and I will check that eventually. A particle moves along the x-axis with position given by blah. Describe the particle's motion and position at t equals 1. So we want to say, where is it? Is it moving to the left or the right? Is the speed increasing or decreasing? So that's a bunch of things. So let's see. First of all, I mean, I could find x of 1, I guess. So x of 1, this will be the position. It's 1/3 minus 5 plus 2 minus 1. So what is that? -6, -4, -12 thirds, -11 thirds. So it's at x equals -11 thirds, I guess. And then I'll find x prime of t, which is v of t. So you want to connect those two things. You don't want to just say v of t. You want to say, or you can say v of t is x prime of t. Either way, you want to connect velocity to the first derivative of position. And this will be t squared minus 10t plus 2. So v of 1 is 1 minus 10 is -9 plus 2 is -7. And then I need a of t, I'm going to say is v prime of t. I need to know this because if I'm going to say if the speed is increasing or decreasing, I need to know if the velocity and acceleration have the same sign or opposite signs. So I don't really care what the value is. I just care if it's the same sign or opposite signs. So 2t minus 10. So a of 1 is -8. So I know the speed is increasing. All right, so what are we going to do? We're going to say at t equals 1, the position is x equals -11 thirds, moving to the left. And we want to say y. So why is it moving to the left? Because v of 1 is less than 0. Speed is increasing because a of 1 is less than 0. So I could stop there, and so I'm going to say therefore, I could stop there, but I'm going to say therefore v of 1 and a of 1 have same sign. Because that's like the real reason. And so I want to like give the actual reason as well. All right, so what do we have left? We have 2 more questions. I'm going to do those, and then I'll go back and I'll check my answers, I think. Will I even check them? I don't know. We need to make this thing differentiable. All right, so I'm going to do bad work on this, but I think that's okay. For it to be differentiable, it does need to be continuous. So differentiability implies continuity. But when you're trying to make it differentiable, you have to force the continuity, because you don't want one of those scenarios where you have like a line with a slope of 2 and then a parallel line with a slope of 2, where it makes it appear as if the derivative will be equal at any given point. So continuous at x equals 1, I would need, basically I need f of 1 from the left to equal f of 1 from the right. That's not the correct notation, but I don't want to spend an hour on these. So I'm just going to say 2 plus a, so I subbed 1 in here, should be equal to, so that's basically the limit as x approaches 1 from the left equals f of 1 equals 2 plus a. And that needs to equal the limit as x approaches 1 from the right, which is going to involve using this branch. And so that'll just be b. So 2a equals b. Now we want to make it differentiable at x equals 1. So I'm going to find f prime. And when I find it, I'm going to leave off 1. So the derivative of the top branch is 2. And that's only when x is less than 1, because I didn't make it differentiable yet. So I don't want to assume differentiability. I want to force differentiability. And then the derivative of the next thing is 3bx squared. And that is valid when x is greater than 1. Okay, so what I need to be true is I need to take 1 and I need to plug it in here, which obviously is just going to give me 2. And then I need to take 1 and also plug it in here, and that's going to give me 3b. So I know that 3b equals 2, and so b is 2/3. And then if b is 2/3, and this is true, I know that 2 plus a equals 2/3. So a is 2/3 minus 6/3 is -4/3. So I'm going to say therefore a equals -4/3 and b equals 2/3. And I think that works, but I'm going to check it eventually in a second. All right, what does this look like? So when I look at this, I immediately think limit as h approaches 0, definition of the derivative. Does it fit the definition? It does if f of x is arctan, which I'm going to write as tan inverse, right? It's f of a plus h minus f of a over h. So we're finding f prime of a. So f prime of x, I memorize this, 1 over 1 plus x squared. So I need f prime of a to equal 1/2. That's a bad 2. 1/2. So 1 over 1 plus a squared equals 1/2. 2 is equal to 1 plus a squared, cross multiplying. A squared equals 1. So a is either plus or minus 1. So I don't like to write my answer that way. Therefore, a equals 1 or a equals, I have like an aversion to plus or minus. I don't really know why. It's like, because, you should kind of like separate them. I don't know. I don't know if other people even care about that. I do. All right, let's see. So I checked the very first problem and we got it. So I'm going to check the second one. So I'm going to do implicit differentiations, imp diff. And then it's, what is it? Y squared minus 2x times y, which is not optional, equals 16, comma x, comma y. And do such that x equals 3, such that y equals -2. So I get 2/5 of the slope, so we got that right. The next one, instantaneous rate of change. So I need to know the derivative, which you should use a template. 5x cubed minus 3x squared plus 6x minus 4 with respect to x. And I want to know that when x equals -2. So you should really use menu 4-2 for this. And I get 78, which is good. The next one, I'm going to actually define the, no, I'm not going to, I'm going to define the function, but I'm going to regret it because you should never really define anything as x because it like messes up every other thing. But x of t is minus 5t squared plus 2t minus 1. Okay, so x of 1, -11/3, got it. We need the derivative of x of t, comma t, when t is equal to 1. I got -7, which I got. And then I need the second derivative. So I can do like a super weird thing here. I can actually just do the derivative of the derivative. I don't recommend this. This is like weird. Such that x equals 1. Oh, see that? Shouldn't have done it, t, such that t equals 1. I get -8, which is what I got. So the other thing I could have done, which is probably better, is take the second derivative. But you can see they're the same thing, which is actually like a really interesting way of looking at it. Like to find the second derivative, even the calculator knows, find the first derivative and then take the derivative of that, and that'll give you the second derivative. But because it's such a common thing, there's a built-in template. And when there's a template, you should use it. All right, so I'm going to define, you know what I'm going to do? I'm going to delete the variable. You know what I'll do? I'm going to start a new problem. Like, why am I cramming all this in one thing? New problem. All right, so now x is up for grabs again. I'm going to define the piecewise function. Let's see what the calculators bring to the table on this. 2x plus a when x is less than or equal to 1. So you should use control equals, control and the button under it, to get that less than or equal to. Just way faster to type it. And so I do, and then b times x cubed. And that's when x is greater than 1. All right, so what do I need? I need I'm going to solve a system. Let's see. Let's solve menu 3-7. So this is like, I don't know why I would really do this. What are my variables? So 2 equations, a and b are my variables. And I need the limit. So this is interesting. I don't usually do this. I'm pretty sure it's going to work. 1 from the left of f of x to equal the limit from the right. The limit as x approaches 1 from the right of f of x. And then I also need the same thing to be true for the derivative. So like what I could do potentially is copy this. Maybe, let's see if this works. So I have to use, you can do control C. It like works plenty well. I have to do some weird thing, but I got it. So there we go. I'm going to use the template for derivatives. I don't honestly know if this is any faster. It might have been faster, just type it. Nah, this is probably right. This is probably faster. I'm going to say, but will it even work? Am I wasting my time? We'll find out in 1 second. So I need the limit to equal. I need the limits of the derivatives to be equal. I want to solve for A and B. So A is -4/3, B is 2/3. Yes. And then for the last problem, I'm just going to have the calculator solve it. So like there's a limit, there's a lot of stuff going on, but I think the calculator is not going to care. I think it's just going to like do its thing. So let's find out. Arctan of x, no, of a plus h. You can just use, by the way, inverse tangent from the trig button. It's just, again, faster for me to type this. Over h, that's an n, over h equals 1/2, and I want to solve that for a. So I get a is 1 or -1. Perfect. All right, so we did them by hand, then we went back and we did basically all of them again by calculator, and you need to be able to do both of those things. So there's really no excuse to not know how to use your calculator, and the calculator can just make you a better student, right? There are things that maybe you struggle with. Calculator's never going to struggle with them, but you can show that, like, yeah, you are understanding the concepts, and maybe you can identify some weak points in like your algebra skills. Maybe you're not memorizing enough. But the calculator is going to get the right answer if you tell it to do the right problem. So, and we were able to do that here. So, all right, that's the end of these notes. So maybe I'll see you in the next notes, or maybe this was all you needed. I don't know, but I hope you found this helpful. So I'm out of here. So thanks for following along.